In the second part, we'll cover some of the other big ticket items in security. We'll start with storage encryption, which allows us to encrypt the storage data. Notice that storage isn't accessible by default and is isolated. However, if a hacker gets physical access to the device or can get through an OS exploit, this might be an important second line of defense. Notice that this is about storage encryption. People often confuse file system storage and storage. They are very different things. File system is low level and pretty similar to file systems on desktop OSs. Storage can be implemented on top of file system, but it's more of an abstract concept. Because of that, we can apply encryption seamlessly to the storage class, but can't do that seamlessness for the file system or SQL class. The Bouncy Castle CN1lib implements a wide range of encryption algorithms that you can use for most common encryption tasks. We enhanced it with the ability to seamlessly encrypt the storage using the encrypted storage class. Once this is applied, the content of storage will be completely encrypted. We use AES for the storage encryption. That's a military grade algorithm that balances performance and security. It should be enough for most purposes. The main weakness with storage encryption relates to key storage. You need to pass the key to the encrypted storage class. This means the key will be accessible to a hacker that might use it. If you need perfect security, you have the option of encrypting the data with a randomly generated key and save that key in the file system. Obviously, this poses the problem of where you will need to encrypt the randomly generated key. Another option is to store an encryption key in the server that will be provided on login. This is the most secure option, but it will block the option of working offline. Another important feature is screenshot blocking. This can prevent potential attack or even misuse when a screen containing private information can be captured. You can't block screenshots on iOS. That feature isn't available there. On Android, we can block screenshots using the build hint to disable screenshots. This also hides the screenshot from the Android Task Manager, which might impact the user experience. If you have a banking app, you might be concerned that the user will grab a screenshot that includes potentially private information, and you might want to block that. Some organizations have a security policy that requires this flag. Copy and paste is a common vector of attack for spyware. If you have a malicious app in your device, one of the first things it might do is peek into the clipboard to see if you have proprietary information there. That's why copying from password fields is always disabled, but you might want to block some other fields that contain proprietary information. You can block copy and paste for the entire app, which might be a bit much for most applications. Alternatively, you can block copy and paste on a specific field using a client property on that field. Jailbroken devices remove important layers of security. They allow apps to be installed outside of the App Store on iOS, which means a lot of the security measures for an app are forfeited. They also allow root access for apps, which allows more exploits where jailbroken devices allow full-on spyware to run in the background. The problem is that it's really hard to detect a jailbroken device, as the very idea of jailbreaking is hiding this fact. So the isJailbroken device method makes the best effort but can't guarantee. If the method returns true, the device is probably jailbroken, but if it returns false, it might still be a jailbroken device that we failed to detect. Thanks for watching. I hope you found this informative.